Last video, we ended with 2-pyruvate. Pyruvate as an end product of the breakdown of one glucose molecule into 2-pyruvate as a result of glycolysis. So each pyruvate molecule is made up of a 3-carbon chain molecule. Each one of these molecules is going to go through what's called the Kreb cycle. The Kreb cycle requires oxygen. So in the presence of oxygen, pyruvate can go into the Kreb cycle. Otherwise, pyruvate is going to turn into lactate via a complex reaction, which we can talk about later. But in the presence of oxygen, so this is aerobic. An aerobic process. So each one of these molecules is going to go through a cycle of the Krebs cycle separately. So that's going to be important to keep in mind, again, when calculating the net production of the products from the Krebs cycle. So starting with, we'll just focus on one side here, over here. So 1-pyruvate enters the Krebs cycle or the citric acid cycle. It's the same thing. So the first thing that needs to happen to pyruvate is pyruvate needs to be turned into acetyl-CoA, and those are 2 carbon molecules. So you'll get 2 of those, and then you'll get carbon dioxide as a byproduct of that reaction. And that's a waste gas, and again, that's why it's important to breathe, because you have all these waste gases, and if you're not getting rid of those, you're going to have difficulty with performance. So acetyl-CoA then undergoes transformation here. There will be more details about what specifically happens in the cycle, but for one turn of Krebs cycle, your net product in terms of electron transporters is you have 3 NADH, and with FADH you get 1. So that happens twice with each pyruvate. So total from one glucose molecule equals, you have 6 NADH and 2 FADH. So those are going to be important when we get to the electron transport chain, and we'll talk about that later, and also there'll be some details about the ATP production that happens during the Krebs cycle and some of the energy investment that's needed. All right, thanks guys.